Gmail to the chapter use? I forget
Okay,
to
no
write it
problem. Let
down.
me put my Gmail in the chat. The recording has begun. My email is um my email is the open and the classroom at gmail.com. Remember, if you're just joining us, please place here or present inside my WhatsApp and just put Bgcse or Bgcse next to your name so I can know what we're dealing with. Okay, so this is the last class for the week. Denari rule. Send here or present, not in the chat, not in this comment section, but send it to my WhatsApp. Okay. Okay, so would you believe it? We are in the last class for this week, right? Last class for this week. Wow, week 1 already finished. That's amazing. Um, and so we see how tonight goes. I can't believe it. We're 1 week closer to your exams. This is amazing. All right. Okay, so today we're gonna be dealing with some. I think everybody's gonna learn something tonight. Probably even
Mr.
something.
Petit,
Go ahead.
when exams is again?
May, June.
Alright.
Yeah, May, June. Let me share my screen with you all. What I want you to do is, tonight we're doing math, social studies, and RK. Please bear that in mind. Math, social studies, and RK. Okay. Yeah, tonight I think everybody's gonna learn something tonight. Um, Tonight we're gonna be looking at extensively. We're gonna be looking at straight line graphs or linear equations. How to graph them. How to find the slope. How to find the y-intercept. Those sort of stuff. So we're gonna look at that. So let's begin. Equation of a straight line. So if you're here for the first time, please make sure that as we are doing this, you are taking good notes. Okay, make sure that you're taking good notes. And what you do right after the lesson, you would send those notes to me. Okay. Admit. No, close. Okay, so let's begin. So does anyone know the general form of the equation of a straight line? What is the general form of the equation of a straight line? Does anyone know the general form?
180 degrees?
No. Who said that?
Rashay.
What's the name?
Rashay.
Deshay?
Rashay.
Rushay. Oh, Rushay.
Yes,
Your
sir.
last name is Neely, right? If I'm not mistaken.
Yes, sir.
Okay, Neely. Okay. No, not 180. I mean the general equation for it.
Is it y equals mx plus b?
Who said that?
dr.
Very good. That's dr. Yes, it is y equals mx plus b. Okay, so the general equation for a straight line is y equals mx plus b. Now this is or some people use c. It doesn't matter. I mean, both of them mean the same thing. Now m means something important, and b, or in some cases c. Some people might use c, some people might use b. It doesn't matter. It's both of them mean the same thing. If your teacher uses c, it doesn't matter. I use b, it doesn't matter. Okay? They're just letters representing something. So the general equation of a straight line is y equals mx plus b. Now, like I say, everything here means something important. And so m, so we could say where, let me fix this, sorry, where m equals, what is m? What we call m?
The gradient.
The gradient. What's another name for gradient?
Slope.
Slope, very good. Where m is the gradient or slope of the straight line. We also call m, yes, the gradient or the slope, but when we say gradient or slope, what we mean is it is, let me fix this properly, it is actually equal to we'd say the vertical rise divided by what? The horizontal shift. Now some people, now that's the technical way of saying it. Some people just say, and some of you might already know it that way. Some people, instead of saying the vertical rise or the vertical shift, sorry, the vertical rise divided by the horizontal shift, some people just say, to be simple, and I usually say it just like this, we just say, hey, this is simply rise over what?
Run.
Rise over run. Remember, let me put it up. Remember that when we say vertical shift, we're talking about moving up and down. Okay, up and down is vertical shift. When we say vertical rise, we mean moving up and down. Okay, when we say horizontal shift, we mean going across from side to side. Okay, so the number in the top, when we're looking at the gradient m, right? This, or when I have the equal sign, all that's just referring to m. Okay, so all that is just referring to m. All of that is just referring to m. Okay, the gradient or the slope. Okay, that is the rise over the run, or the vertical rise divided by the horizontal shift. Like I said, the vertical rise refers to the up and down movement. So movement up and down. So movement in the y direction. Okay, so movement in the y direction. And horizontal shift, if vertical rise is movement in the y direction, what do you think is horizontal shift?
X direction.
Yeah, movement in the x direction from left to right. So movement in the x direction. Okay, so the top number tells us how we're moving up and down. The bottom number tells us how we're moving from side to side. It's the same thing from rise over run. We say rise is up and down, run is from side to side. Okay, so m, think about it, this simple number m, right? This simple number, I know it's a letter, but the letter represents a number. This simple number, which is going to be in front of x, right? That simple number is going to tell us how we're moving up and down. Okay, how many movements up and down we go. Okay, sorry, let me let this person in to the meeting. Give me one moment. Okay, so let me just go back here. Let me know when I can move it.
We're done.
Okay, I can move it, they say. Okay, so there's another, so we know that m represents the vertical rise divided by the horizontal shift or rise over run. That's what m is. M is the slope. Okay, m is the slope or the gradient. Now what is b? Okay, now we coming back to b, but here I just want us to do some examples with I want us just to do some examples with this. Okay, Okay, so okay, from so this is some example. This is some examples. Okay, so examples, easy examples we're gonna start with. So from the equations given, now what type of equations these are? These would be what type of equations are we talking about when we're looking at a straight line graph? What type of equation is this?
Liner.
Linear. Very good. It's linear equation because the highest power of x is 1. We're not doing x squared, x cubed, x5, x6. The highest power of x is 1. So we're dealing with a linear equation. Okay. So from the, we could even say from the linear equations given, and I know, sorry, that I have to change that, but from the linear equations given, determine the slope. Okay. So we're gonna start off pretty easy, and then we're gonna intensify it. Okay, so let's start off with an easy one. So it's the first one, number 1. So we have insert, boom, y equals 2 over 3 x plus 7. Sorry. Okay, so do that for me. Don't share your answer, just do it first, and then we're gonna discuss the answer later. So the second one is y equals 1 over 2 plus 5. The third one is x. Sorry. Now let's keep it simple. Let's say x plus 8. So write these down and tell me, all I want to know is what is the slope. Okay, so here we have 1, 2, 3, 4, 5, 6 examples. And these are all linear equations. Why they're linear equations? Because we're not dealing with stuff like x squared, x cubed, x4, or whatever. We just have something simple, just x. And if it's x by itself, it just means x to the power of 1. So we know we're dealing with a linear equation. Sorry, let me let these persons in. One moment. Let me allow them to come in. Okay, so let's go here. And so we have these examples here, and all I want to know is what is the slope. So we're going to start with the first one. And so my question to you all is, what is the slope for this one? What is the slope for this equation? Anyone can answer. What's the slope?
2/3.
2 over 3. Anyone agree with her? Anyone disagree or agree with her? We agree. Why is it the slope?
Okay.
Why is that the slope? Go ahead. Why is that the slope? No one? Come on. Y'all sleeping with me already? Hello? Can you all hear me?
Yes, sir.
Yeah, why is 2 over 3 the slope?
Because there's the number in front of the X.
Very good, because it's a number in front of the x. Remember the example that we started off with? Remember, m is the slope. That's the number in front of x. Okay? And so definitely 2 over 3 is the slope in this case. Okay? So 2 over 3. Okay, for the second example, what number is the slope? A half. Very good. A half. Why a half?
Because it's
It's a number in front of the x. Very good. 1 over 2. Remember also, what is this saying? This is saying that if we look at 2 over 3, this is saying that how much movements we're going to go up and down? 2, right? Because
2 times.
because 2 movements up. Okay, so remember, the 2 or the number in the top tells us how we're moving in the y direction up and down, and the number at the bottom tells us how we're moving across. Okay, that's very important. So this is saying that for every 2 units you go up, you have to go 3 units to the right. Again, for every 2 units you go up, you have to go 3 units to the right. Okay, this one is saying for every 1 unit you go up, you have to move 2 units to the right. Okay, so the slope here is 1 over 2. What's the slope for this one?
3.
Very good. The slope for this one is 3.
3.
Why is it 3?
Because
There's a number in front of the X.
Very good. Very good. So I have a question. We have 3 here, right? Notice that we just simply have 3. What does the 3 tell us? Does the 3 tell us to move in the y direction, or does the 3 tell us to move in the x direction?
The Y direction.
So how are we moving in the x direction?
1.
1.
Who said 1 and why you say 1?
Because 3 is a whole, and that
And that
equals
equals
3 over
3
1.
over 1.
Who said that?
Saria.
Zaria. Very good, Zaria. Very good. Very good. 3 is equal to 3 over 1. And so this means that we move in 3 times for every 3 units we go up, we have to go 1 unit to the right. Okay? So the 3 tells us the y direction, and the 1 tells us the x direction. Very good observation. So even though they didn't say 3 over 1, you know that 3 can be written as a fraction, as 3 over 1. And so that's how it goes. Very good observations, Aria. Okay, so this one, what's the answer for this one? What's the slope for this equation?
8.
8.
8, very good. So the slope here is 8. What's the slope for this equation? This one?
7 over
7
3.
over 3.
No, sir.
Negative 7 over 3.
Thank you. Negative 7 over 3. Be careful. Be careful. Negative 7 over 3. Okay, and that negative means something important. That negative tells us that we're going down. The slope is going down. Really, it's okay. What it means is that the line is going to look like this. Okay, it's going to look like we going down a ladder. Okay. Now, the last one is a tricky one. I don't know if y'all got it. What is the slope for that one?
1.
1.
1?
1.
Why would it be 1?
Because X. Renaissance known as
X
X.
equals 1.
Because x equals to 1.
Y'all close, but y'all saying it wrong.
A
A
variable means 1.
variable means 1. A variable don't mean 1. A variable
When
doesn't.
it by itself, the variable spot 1 stands for 1.
Still saying it wrong. The way how we'd say it is that. Okay. So when when
In line equation, the highest term is 1.
Okay, yeah, that's good. But when a variable stands alone, its coefficient now, the coefficient of the variable, although it may not be written, I spelled coefficient wrong, my bad. Its coefficient, although it may not be written, is 1. So its coefficient is 1. So when a variable stands alone, okay, say for example, if we have just a variable x, right, and nothing is in front of it, then the coefficient of x is 1. Make sure it not x means 1 or x equals to 1, but the coefficient of x is 1. Okay. So that's why. So let's say for example, if we have if we just have the variable p, what's its coefficient?
1.
Its coefficient is 1. So this p is actually equal to 1p. X is equal to 1x. Q is equal to 1q.
1Q.
Not that it's equal to 1 or it's equal to 2, but it's equal to 1q, right? F is equal to 1f. S is equal to 1s. Okay? And that's what we mean. So when a variable stands alone, its coefficient, although it may not be written, is 1. So if we have x, then the coefficient of x is 1. Okay? Is that clear?
Yes, sir.
Okay. It could get a little more interesting than what we have here. What I mean is, can I move this?
Yes, sir.
No, sir.
No, he said no. So in our next examples, we're going to look at it when things are a bit different. Okay? You have to be paying much attention. We good? All right.
Yes.
Okay. All right. So for example, so for here, the slope, okay, is equal to 1. What's another word for slope?
Gradient.
Gradient is another word for slope. So the question could ask you, what is the gradient? You don't have to be afraid or paralyzed or scared or anything. The gradient is equal to the slope. Same thing. I have some other examples for you, right? Let's say, for example, so let's make it a little bit more interesting. So still doing these things here, but let's say, let me move all these ink from here. Still determining the slope. Everything is good. But let's consider these examples right here. Any questions for me before I move on with some more examples?
No, sir.
No? Okay,
No,
good.
sir.
So let's say, for example, we have something like, say, y equals 7. Okay, or you have something like y equals to 8. So in each case, give the slope. We say you have something like 2y equals to x minus 5. I don't like how the x look. Why I look like that? Anyway, well, let's say we have something like 3x equals to 3x plus 2y equals to 5. So let's just consider these 4 examples, and I want you all to tell me the slope in each case. So let's begin. So here, what is the slope for the first question?
7.
Who said 7?
Rashay.
Rashay. So someone said 7. Someone said the slope is 7. Anyone else? Nancy, where's Nancy? I am from Nancy. Dior, I need to hear from you. Who else I need to hear from? Ricardo, I need to hear from you, Ricardo. Especially my Bgcse students, they should know. What is the slope?
What if
What if
these?
these?
I'm gonna skip 7 over 1.
7 over 1. Okay, so not 7. 7 over 1. Okay. Right.
Is it
Is it
0?
0?
Who said that?
Dior.
Dior. Okay. So you asking me or you telling me?
I'm
I'm
sure,
sure,
but
but
I telling
I
you.
telling you.
You telling me? But you're not sure. She say 0. How she get 0? Where 0 come from? Okay. Alright. Anyone else?
It'll be the
It'll be the
equation doesn't
equation
have a
doesn't have
slope.
a slope.
It'll be that the equation does not have no slope. So he said no slope. Okay. Alright.
Okay, now I
Okay,
can
now
see
I
who
can
all
see
the
who all the
answers.
answers.
Okay, so the first thing we have to do when we considering determining if something have a slope is it must be of the form. We must first write it as y equals mx plus b. We must have that in that form first before we can even talk about determining the slope. So here, this equation right here is not of the form y equals mx plus b, right? But we can make it of the form y equals mx plus b. Okay, so we have the y, so that's good. So we have the y. Okay, we have the y. We have the equal sign. That's good. We also have the 7. That's good. What are we missing?
MX.
MX.
The
MX.
Very good. Right, we are missing. Oh, sorry. Someone is waiting. I know they have been waiting for 10 minutes. I know. I don't see any notification from you, Ryan. Okay. So we have the 7, which is b. Okay. We have the plus sign because it's a positive 7. Now the x, the reason why we don't see the x in this equation is because they kind of hiding it from us. What it really is 0x. Okay, they don't put it, but it's 0x, and the reason why it's 0x is because what is, okay, let me help you out. What is 0 times 4?
0.
0.
Okay. What is 0 times 5?
0.
0. What is 0 times 6?
0.
Okay, what is 0 times x?
0.
Very good. And so they're saying, okay, 0 times x is already 0, and 0 is nothing. So we don't even have to write 0x. We just have to write y equals 7. You see what I'm saying? So y equals 7 really means, if we were to expand it out, what it really means is y equals 0x plus 7. And so if that's the case, then what is m, or what is your slope?
0.
0.
Very good. Your slope is 0.
0.
Okay. So and if that, since that's the case, and let me just keep it. Just keep this 0x. We know that this move. So if that's the case, that means that our slope in this case is actually 0. Okay. So slope equals 0. Okay. So whenever you see something like y equals 7, write it out in slope intercept form as y equals 0x plus 7. And then from that, we can clearly see easily that the slope is 0. Okay. All right. Any questions for me? Some people, you're lost. Tell me. Let me know if you're lost. Let me know if you know what's going on here. Need me to explain it over.
I do.
Who's that?
Daria.
Zaria. Okay, Zaria says, Mr. Petit, explain it again. All right, we can explain it again with number 2. That's why we have 2 of the same question. So we have y equals 8. Okay, so let's begin. Let's do another one. So we're gonna do y equals 8. So for y equals 8, remove all these stuff. So for y equals 8, for this one, what we do is we're gonna write it as y equals 0x plus 8. And when we do that, we know immediately that the slope is going to be equal to what?
0.
0.
0.
Because the slope is always the number in front of x. I'm going to do another one. Let's do y equals to, so I'm going to do another example before I get to those other ones. So let's do y equals to 75. If we do that, what's the first thing we need to do?
Y equals 0x plus 75.
Very good. Y equals to 0x plus 75. And so the slope, therefore, is what?
0.
0.
Very good. Do I need to do any more examples from this?
Also.
No, sir.
No,
Good.
sir. Yes, sir.
Yes. Who say yes? Okay, so let's do one more. So let's say, for example, we have y equals, this is another example, y equals, there's probably someone in here who's 13, so let's use 13. And so is going to be y equals to, what are you going to put? 0x
Plus
plus
13.
13. Very good. And so therefore the slope now is going to
0.
be equal to, very good, it's going to be equal to 0. So every time we have y equals to some number, okay, we don't even have to express it like that if we don't want to. We already know that the slope is 0. Okay, so y equals to 7, y equals to 8, y equals to 13, y equals to 75, all of that, the slope is 0. Okay, so we good? Let me know if I could move on.
Yes,
Yes, sir.
Okay, so alright, so did anyone answer this one?
Yes, so.
Yes, sir.
Yes.
Yes.
And what if
Who
we
said
want?
the same one? So we need to find the slope of that. Oh, sorry. Okay, so from the linear equations, determine the slope of, we're going to do this one. Okay, this one is interesting, but we'll see how to do it together. Okay, so for those persons who already did it, tell me what your answer is. Already did it.
1.5.
1.5.
I
You got,
mean, half.
Half.
you mean 1 over 2?
Yes, so.
Yes, sir.
She got 1 over 2. Anyone else?
1?
1.
Someone said 1. Who said 1?
Rashay.
Rashay said 1.
I go
I
with
go
1.
with 1 too.
We got 1 too. Okay. Nancy, I want to hear from you.
Okay.
Okay.
Based on
Based on
my
my
division,
division,
I get
I
on
get on
1.5.
1.5.
You mean 1 over 2? A half.
Yeah.
Yeah.
I mean, yeah,
Half.
sorry.
Yeah, sorry.
It will
It
half
will
it.
half, sorry.
A half. Okay. So we have a half or 1. Okay, so remember that the first thing that you do when you're trying to determine the slope, you must express it in the form y equals what? Mx plus b. Okay, that's the first thing you have to do. Now, if we look at this equation, is it of the form y equals mx plus b?
No.
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 No, sir.
No. What's the problem?
I have
I
a
have a
minus
minus
It's too
It's
wide.
too wide.
It's too
It's too
wide.
wide.
It's too wide. It's too wide. That's the problem right there. That's the bigger problem. It's too wide. Okay, so what we have to do is we have to get rid of that 2. Okay, we'll get rid of that 2. And so how do we get rid of the 2?
Divide.
We have to
Divide.
divide both sides. So it's going to be 2y equals x minus 5. We divide both sides by 2 because that's the opposite of multiplication, right? So now when we say divide both sides by 2, what we really mean is we divide each term by 2. So this is going to be divided by 2, and this is going to be divided by 2 as well. And so what happens there is that these 2 cancels out. This goes with that. And so we are left with simply y equals x over 2 minus 5 over 2. Okay? And we could write that as y equals 1 over 2x minus 5 over 2. And so do we have it in slope-intercept form now?
Yes, so.
Yes, so.
Yes,
Very
sir.
good. Yes, we do. We have y equals a number, x. Now, some people may be confused. They say, well, Mr. Petit, this is not a plus. But when we say y equals mx plus b, it could be plus or minus. It doesn't matter. Okay, so this is fine. So y equals m, which is a half x minus 5/2. So the slope here would be what?
A half.
A half. Very good. So the slope would be a half. So the slope in this case is going to be equal to a half. Okay, so the slope here is a half. Okay, let me know when I can move it.
You can move it.
Okay, so let's do another example like this one. So let's do something like, before we even get to that other example that I gave you, let's do something else. Like say, and I want you all to do this one on your own. So let's say we have 7y x minus, say, 9. Okay, so find and determine the slope of this linear equation. Once you finish, tell me what you got. The moment you're done, you can say the answer.
1/7.
1/7. So someone said 1/7. Anyone else?
1/7.
1/7. Okay, you already have that.
I go the same thing.
You got the same thing. Okay,
Same thing.
same thing. Okay. Okay, so how did we?
When you
Go
get
ahead.
it, you wanted to convert it back to a fraction.
What?
Okay, like let's say you did the you did it and you got decimal. You want to turn it back into a fraction, basically.
Always express it. If it can be expressed as a fraction, express it as a fraction.
All right then. So
If
one
it
over
can.
7.
Yeah. All right. So how did we get, for those persons who got 1/7? Let's see. Remember, it's y equals mx plus b. That's what we're looking for. We're trying to express that into that form. It's not in that form because we have 7 out front. So what we need to do is we need to remove that 7. Okay, and we do that because 7y means 7 times y. So in order to get rid of that 7, we have to do the opposite of multiplication, which is what?
Division.
Division. Okay, and so with that being said, we have 7y equals to x minus 9. And so we're going to divide both sides by 7. That means we divide in every term by 7. Okay, and then we're going to cancel. So, of course, this with that. And so y is going to be equal to x over 7 minus 9/7. Which means we have y is going to be equal to 1/7 times x minus 9/7. And so our slope here, clearly, our slope is going to be 1/7. Okay. Alright, so let's go back to that question that I asked you originally. And let's see if we could determine what is the slope for that one. Okay, so this question was the third one. So it was the final one. You wasn't finished? Someone wasn't finished? Oh, okay, I guess not. Okay, so we're gonna look at this one. So let's consider it. So it says from the linear equations given, determine the slope. Anyone got an answer for this one? Anyone got an answer for this one yet? Or we didn't touch it yet?
Didn't finish it.
Okay. Okay.
Is it negative 3 over 2?
Negative 3 over 2. That's the all?
Yes, so.
Okay. Alright, so someone said negative 3 over 2. Anyone else?
I got the same thing, right? But is it weird that if I put okay, when you say negative, right, the entire thing will be negative or just like the bottom number?
If one number is negative at the top or bottom, the whole thing is negative.
Okay, so I got the same thing.
Yeah. In decimal form is 1.5. Okay, so the idea here is, remember, we have to change it into the form y equals mx plus b. And if we look clearly, we have 3x plus 2y equals to 5. That's not in y equals mx plus b form, right? Plenty things is a problem. The first thing is that this 3x is not supposed to be here. Okay? You understand what I'm saying? Let me write this properly so you can actually see what's happening. Like, what I'm saying is, if we compare the top equation, so this is 3x plus 2y equals to 5. If we compare the top equation with the bottom equation, clearly they're not the same. Okay? This mx is on this side, right? That's the first thing. So this 3y cannot, so this 3x cannot be here. We have to send it over. That's the first thing. The next thing is that the y has a 2 attached in front of it, and this y has nothing, just 1. So this one is just simply y, but this one is 2y, so we gotta do something with the 2. Okay, so two things we have to do. We have to move this 3x, okay, and then we have to move this 2, and then and only then we can be able to determine what the slope is. Alright, so let's do that. So in that case, erase our link. So with that being said, this is going to be 3x plus 2y equals 5. The first thing we're going to do is send the 3x over, leaving us with 2y equals to, when we send the 3x over, what happens to the 3x?
Becomes a negative.
It becomes a negative 3x. Very good. So it becomes a negative 3x once we send it over, plus 2y. Oh, no. Sorry, I'm so sorry. Plus 5. Yeah, plus 5. Okay, so what is the next step?
Divide those by 2.
Divide everything by 2. Very good. So 2y equals negative 3x plus 5. Divide everything by 2. And so after that, we're going to cancel, right? So we're going to cancel this 2 with that 2, leaving us simply with y equals to negative 3 over 2x plus 5 over 2. And so once we have it like that, what's our slope?
Negative 3 over 2.
Negative 3 over 2. Okay, so our slope here is going to be negative 3 over 2. Okay, so we're going to do one more example like this before we move on to the next one. Okay, so negative 3 over 2 is the slope. So moving right along. Okay, so let's see who's here. Abigail, very good. Sean, good night. Okay. Alright, so let's move on. This is going to be, so we're going to do something similar to this. Something similar. But this time, let's change up the numbers. Let's say this is 6.
Well, I wasn't
Why
finished
wasn't
writing
finished
that.
writing that? You wasn't finished writing it? Okay. Good. Alright, take a screenshot for me, please. Thanks for letting me know. While we're here,
Not a
if
problem.
you have,
I got it.
okay, good. If you are here, please send me a message on WhatsApp saying that you're here. Just say here on WhatsApp, send me the message. The next thing that I want you to do too is on the side of your, after you say here or present, make sure I put either Bgcse or Bgcse right under that so I could know which one you're doing, because I could forget. I could really forget. And so please place that. The reason why I say that is because like for example tonight I forgot that one of my students was actually doing accounts. So and so I need to keep up to date. So please underneath your name place either Bgcse or Bgcse so that I can know what to send you and what not to send you. Alright. Okay, that makes it so much easier. Alright, thank you. Alright, moving right along. So okay, so yeah, so let's consider another example. So let's say if we had 9, and let's say this was 4. Let's say this was 14. I don't want a 14. 14 is going to be interesting. Let's just do 15. Good. Alright. Okay, so complete this. Do this one quickly. And let me know what your answer is once you do it. I think you just look at it and already know what the answer is. And you can just look at it. But I'll give you all a chance to think about it.
Negative 9 over 4.
Who said that?
Cooper.
Cooper? Cooper? Wow. BJC. Wow. Okay. All right.
-9/4.
-9/4. Okay.
Yeah,
Yeah,
negative 9
negative
over
9 over
4.
four.
-9/4. Okay. I wonder what if y'all wrong? Y'all saying it so confidently. -9/4. All right. Okay, so remember the idea here is that we want to express it in terms of y equals mx plus b. And so then we can clearly see that whatever m is, that's the slope. Okay. And so since we're using that idea, what we're going to do is we're going to take 9x plus 4y. That's going to be equal to 15. The first thing we're going to do is send the 9x over. When we send the 9x over, it becomes negative 9x. And so we have 4y is equal to negative 9x. Okay. Still plus 15. Now we want to, what is the next step that we're going to do at this point?
Divide the
Divide
divide all
divide all
by
the by
4.
4.
Divide everything by 4 because we want to get rid of that 4 out front. And so we divide everything by 4. Every term by 4. And so this cancels with that. So we get left with y equals negative 9 over 4 x plus 15 over 4. And so that means that our gradient or our slope is negative 9 over 4. So the slope here, in this case, is going to be equal to negative 9 over 4. So what that means, right, is that we are going to move 9 times downwards because it's negative and 4 times to the right. That's what that means. So the slope tells us y direction and x direction. How we're going to move upwards and how we're going to move to the side. Okay.
So
So
so does it
so doesn't
matter
matter
when you move
when
to
you move to
9x?
9x.
Say it again.
Doesn't matter
Doesn't
when you
matter
move
when you move
the
the
9x and plus
9x and plus
15?
15.
Okay. You mean what you're doing is you're combining this with this, right?
Yeah.
Yeah.
Because 15 over 4 is not the gradient. That's something else. That's the y-intercept. So this doesn't tell us
No, I
why
No,
we
mean
I
move.
like
mean
you
like
move
you
the
move the
9x
9x
in front of
in
the
front of the
15.
15.
I saying
I
it doesn't
say it
matter
doesn't
when you
matter
move
when you
Oh,
that.
move that.
oh, I put you when I with the 9x. I put it in front of the 15, not in the back of the 15.
Yeah.
Yeah.
Oh, okay. Okay, very good question, Floyd. So he's saying, okay, what if we have what if we have 9x? Sorry for those persons who didn't write that down. Let me just do an example and then we go right back to that. And then we have 15 and he's saying, okay, what if we send it to the back? And so if we send it to the back, it'll be 4y equals 15 minus 9x. Okay. That's fine. That's okay. Because they mean the same thing. The only problem with that, not problem, but you just have to, know what you're doing, is that when we divide by 4, it'll be y equals to 15 over 4 minus 9x over 4. So you have now, it's not really in the form y equals mx plus b yet, right? I mean, it is, we just have to switch it. So we just have to switch it across. I mean, it's not necessary that you switch it. I mean, if you know what you're doing, you immediately see the slope from here. But yeah, it doesn't matter once you know what you're doing. I wouldn't recommend it, but if you know what you're doing, you could keep it like that. But I usually just put it in front. Okay, but they mean the same thing. These are both the same lines. So this line and this line are the same thing. Okay, so both are correct answers. Does that help to answer your question, Floyd? Or you still have another
Yeah.
question?
Yeah.
Yeah.
I just
Yeah. I
wanted to
just
know
wanted
if
to
it
know if it
mattered or not.
mattered or not.
Okay. In terms of correct answer, they're the same answer. Okay. They're the same answer. And they're the same line. They're really referring to the same line. So not both of them are correct. It's just that this one is more true to the form y equals mx plus b. That's it. Wow, Miss Tamara. Thank you. Very good. Very good. Tamara's already sending in her notes. Very good. I mean, her handwriting is incredible. Very good. Thanks for sending it already. I have no problem if you send your notes early. That's fine. At least it's better than forgetting to send it. Okay, so that's that. So that's the slope. Now, when we first came here, we talked about the slope. We started off with the general form, and we said that the slope is rise over run. Sorry, we said that the slope is vertical rise divided by horizontal shift. Or we said that the slope, which is m, is rise over run. There's another formula that I didn't give you for the slope that I should give you. Okay, and that's what we're gonna be using moving forward. Okay, to determine what the slope is. Okay, the formula that I did not give you, which I should, is the following one, and some of you already know it by heart, and it is the following. So when we say m, another description of m, okay, another description of m is going to be, yeah, it's the gradient or the slope, but its formula is the following. So m is going to be equal to, and we did this before in this class. We did this the end part of last year. This was y2 minus what?
Y1.
y1. Very good.
Oh yeah, I remember.
Yes. And
And
it's
then
going
it'll
to
be
be
x2 minus x1.
very good. x2 minus x1.
That's the formula I told me he was gonna do the first time. Give him a trouble. Never worry.
Yeah. Right. So this is the formula for the slope or the gradient. Okay. And all that means, okay, all that means is exactly what it says. Change in y. Okay. All right. Change in the y direction divided by change in the x direction. That's literally what it's saying. That's literally what it means. Okay.
Got noisy. Damn.
You can't. Your mic is not muted, please. What's also important here is that what we need to understand what this means. What does the slope mean? Okay. In layman's terms, when we say the slope, right, or gradient, what do we mean? What does that mean? So that's just talk about if someone, you're walking down the street and someone say, okay, you say, what did you learn in class today or this evening? You say, well, we learned about the slope. You say, okay, but what is the slope? What does that mean? Yeah, I don't know. We can tell you what it means, right? So what does the slope mean? Like, what does it mean in layman's terms? So what does the slope mean? Anyone know? Like, what does it mean in layman's terms? We did this before.
Wait, give me that
Like the steepness of it or something.
The steepness of what?
A line of an angle.
Not the angle, but the steepness of the line, all right? So the slope tells us how steep a line is. So obviously the greater the slope, the steeper the line. Okay, that's what we mean by slope. So if we have say we have this line, and this line is like, say this line is like this, and we have another line, right? Hopefully y'all can remember this. We did this last year. This line is like that.
Yeah, remember.
Which one is steeper? The blue one or the red or the green one?
Green one.
The green one is steeper. So which one has the greater slope?
The green one.
The green one. Very good. Okay. So if we call the slope of this line M1, and we call the slope of the one in green M2, we can say that M2, which is greater, M2 or M1?
M2.
M2 is greater. Okay. So M2
Oh,
is
wow.
greater. Oh, we good?
Yes, sir.
What we saying wow about? I know math's exciting, but I know if it's that exciting.
Sorry, but I have to set this microphone at the wrong time.
Oh, you had the wrong sign. Okay. All right. Yeah. So the slope is gonna tell you how steep the line is. All right. So a line with a greater slope is gonna tell us tell us that the line is steeper. Let me show you what I mean in practical terms. You may be wondering, Mr. Petit, what you mean? Let me show you. So let's go to, this is my favorite part. So let's go to decimals, right? I love using graphing calculators all the time. So let's say we have a line, right? So give me a line is going to be y equals to, let's say, 2x plus 4. No, let's do plus 1. Yeah, okay. So that's the line, right? So we see this line, them in red, is a straight line, right? So you see, this equation tells us exactly this line. You see what I'm saying? This is the equation of that line. This same thing, this y equals 2x plus 1. That's what we're seeing graphically. Okay, it's cool, right? It's amazing that we could put this in letters and numbers, and we could get a whole line. That's crazy, right? You know, it's very cool that this tells us exactly the points on this line. At any rate, enough about that math and its beauty. If we have a line, say a line with a slope of say 6, we expect it to be what? Steeper, right? Because it has a greater slope. You agree?
Yes, sir.
Good. So say we have 6x plus 1. Notice which one is steeper.
Y equals 6x plus 1.
Very good. Y equals 6x plus 1. So it's definitely steeper. Okay, so what made it steeper? Well, it has a greater slope. Okay, and so the slope tells us how steep the line is. All right. Now imagine if we had a slope less than 2. So if we have a slope less than 2, say 1, so 1x plus 1, we can clearly see that this line is not as steep as the red one, right? Because the red one is 2x, it has a slope of 2, and this one has a slope of 1, and so it's not as steep. Okay, and so hopefully that gives you an understanding of what's going on here. Do we understand what I mean? How the slope tells us how steep it is. Good. There's another thing that slope tells us, right? The slope also tells us not only how steep it is, right? But the slope also tells us not only how steep a line is. The slope tells us the orientation, or, and I put that in quotation, the orientation, or I would say the direction, and this is in quotation, the direction of the line, if that makes any sense. The slope tells us the direction or the orientation of the line. What I mean is positive slope. This is because if we have a positive slope, we know that we're climbing. But if we have a negative slope, then we know that we are descending. So it tells us the direction. So what I mean is, if we have a positive slope, we know that we're climbing. So we're climbing the ladder. That's the direction of the line. But if we have a negative slope, we know that we're going down. Okay. So the slope tells us the orientation or the direction of the line. That's why the slope is very important, right? Slope is very important with a line. It tells us the orientation or the direction of the line. Okay. Positive slope, we know we're climbing. How we get 8 foot? Oh, okay. Okay, sorry, I was looking at my other phone, and it said that the time is 8:15, and I say, how we get 8:15?
We'll say what?
Wow, good thing we ain't going by that time.
I just want to say you were according to that.
No, that's the wrong time. Okay, so so the positive slope means to be ascending. The negative slope means that we are descending. Okay, so what do we mean? Let me show you. Can I move that?
Yes, sir.
Yes,
Okay.
sir.
Oh, nice writing it.
Start writing.
Oh no, we wasn't right on anything.
No.
What you say, Miss? You say, Miss Joseph?
Supposed to be writing there.
What you think? You just have it there for pretty? Oh, just for pretty, Mr. Petit. Just have it there for pretty. Oh.
Oh,
What you mean was it on the place?
Think it's
Imagine
weird.
a note she be missing.
That's if she is sending notes. Ask her if she is sending notes.
Nancy don't send her notes. I use send my notes. You know that. You know. Don't come for
None.
me.
Okay, let me carefully go on my WhatsApp chat to everyone to see.
Please do. It's updated. Yes, please.
Why, Cooper? You know it's bad.
No.
Cooper wants to see so bad. Cooper like, yeah, let's see.
No.
Don't stop, man.
So, Mr. Petit,
Yes, sir.
can you make the slope go up and down on the same line?
Then that wouldn't be a straight line graph. That would be something that we call a piecewise function. Okay, it wouldn't be a straight line graph. Okay. But with the equations that we're talking about, it only goes one direction. Either climbing or descending. Okay.
So what's the point of this slope?
What's the point of the slope? See, the point of the slope is, number one, in the exam they ask you to find the slope. That's one. And two, the slope helps you when you're graphing the line. Okay. So when we start to graph the line, the y-intercept and the slope is what we're going to be using to help us to graph the lines. Okay.
So this slope can help us in everyday life. I finished. You can change it whenever you're ready.
Will it help you in everyday life? It depends on what your job is. It depends on what you want to be and where you want to go.
It can help you in teaching and what else?
It can help you to get your Bgcse and get your Bgcse. That's what it
I
helps you.
said job.
You can't get a job without that. You can't get a job. Can't get a job without that. Okay. All right. Okay. Yeah, I figured. Yeah, Nancy. I don't have your notes from last night.
Mr. Petit,
I promise you. Check your Okay, so let's go back
Mr.
to.
Petit, you know it's in red. That's Honduras.
I telling you, check it, check. You ain't
You
saying that to
have
me.
my notes. I'm
No, not
telling
from
you.
not from last night.
Uh-oh.
Not from last night.
Mr.
You
Petit, do you have my private, the private notes and
mm-mm, I ain't have that. Okay, so a negative slope. Give me one moment. Give me one moment. Something is happening. So, like someone fall or something like that. Give me one moment.
I have them on my phone, Mr. Petit. I will resend them to prove to
Give me
you
one moment.
that they were there.
Okay, I'm sorry about that. Yeah. So what I was explaining is, and you're probably gonna have some talking in the background. We having an issue here, so please bear with us. Okay, so notice what's gonna happen. Negative x plus say 3. You see what happens, right? This one has a positive slope. Okay, this one has a negative slope. So you notice how this one descends and how this one ascends.
Yes, sir.
Okay, so negative slope descending, positive slope ascending. Okay, so we clear on that?
Yes, sir.
All right, good stuff.
Yeah, so.
All right, good stuff.
Yes,
Both
sir.
of those look ascending.
Say it again.
I
Thank
say,
you.
to me, both of those look ascending.
Both.
From
Okay,
different ways.
from different ways. Let me show you what I mean. What I mean when I say ascending and descending, so you could understand what we mean when we say ascending and descending. Okay. Clearly, it depends on how you're looking at it, but let me show you what I mean. So the one in red, we say it's ascending because it's as if you're climbing a ladder. Okay. For the one that's descending, we say it's descending because it's as if you are coming down. Okay. Does that clear it up, or you want me to explain it a different way?
I mean, you can't clear it up because you could look at it both ways for either one.
Okay, let me show you what we really mean. See, think about it. What we really mean when we say ascending and descending or increasing and decreasing is the following. As the x values increase, so let's look at our x values. So here we was at 0, right? Then we move to 5. When we go from 0 to 5, notice that our y value was, say, let's say that this is 4. But by the time we get to 5, what happened to our y value? It's like 13, 14, really 13. You see what I'm saying? So as we increase in the x direction, the y direction also increase. You see what I'm saying? So that's why we say it's ascending. Because as we increase from 0 to 5, the y increase from 4 to 13. And as we increase from 5 to 10, the y increase from, say, 13 to, say, that's probably like 23. You see what I'm saying? So as we increase along the x, the y also increase. So therefore we say we're increasing or we're ascending. Okay. But if we look at this one, as we increase in the x direction, the y direction is going down. Like as we move from negative 20 to negative 15, this is from, let's say this is say 23. So this is 23, let's say. And then if we, by the time we get to negative 15, it goes down. So it goes down to that's just 19, that's 18. And then as we increase again on the x, we see that here we was at, say, 13. And then by the time we get to negative 5, we are at, say, 7. Okay. So as we increase in the x direction, the y direction is actually going down. We actually decreasing in our y values. Okay. But but for the red one, as we increase along the x-axis, the y numbers or the y values is actually getting bigger. Okay.
All right.
Okay. Okay. So that's that. So that's what we mean when we say increasing and decreasing. So the slope is going to tell us. Go ahead. I thought that was someone asking a question. Okay, so the slope is going to tell us what's increasing and what's decreasing. Okay, so let's actually use our formula for once in some questions. So let's see.
Mr. Majid,
Go ahead. Go
we
ahead.
ain't doing no past papers today.
You want me to do some past papers?
I
No, we
just
ain't gonna do.
asking.
We ain't gonna do past papers. We're gonna be doing theory today. More theory.
Right.
More notes. More notes type stuff.
Uh,
Yeah, I figured. I said to myself like, I didn't really give them no notes or marks like that. So
Mr. Majid, we got two subjects after that. We gotta write down half.
you get 2 subjects after that. Not everybody else.
But
You
yeah,
don't put that on
We
everybody
do.
else.
some people do.
Some. That's you and them. After this, Nancy go and sleep.
That's Nancy. What with the rest of us?
Agreed.
Nancy go and sleep after this. Who else go and sleep after this? All my BGCSE people gonna sleep after this. So I need to make sure they have
Some
something.
goodbye then.
No, sir. After this, you get study more.
After this, we gotta study. Okay.
You when you go to bed.
Okay. Alright, so okay, so okay, so um so given so this examples. So given anyway, find the slope. Find the slope of a line that passes through the points 30 rather, and 07. I don't like this. I don't like the 0, 0. Let's do 27. So find the slope of a line that passes through the points 3, 0, and 27. So in order to do this, the first thing we have to do is we know that the formula for the slope is this, right? So we have to first figure out, okay, what is y1 and what is y2, then what is x1 and what is x2. Okay, so y1 is going to be the y value on the first point that they give you, which is 0. y2 is going to be the y value on the second one. That's y2. x1 is going to be the x value that they first give you, which is 3. And x2 is going to be the x value that they give you secondly, which is 2. Why did this is so strange. I'm sorry. I use a different color. You notice that? X2 is going to be 2. Okay, so let me explain again how we got those values. y1 is 0 because the first y value that we get is 0. y2 is 7 because the second y value you get is 7. x1 is 3 because the first x value they give us is 3, and x2 is 2 because the second x value they give us is 2. And so therefore our gradient or our slope, which we're going to call m, so m therefore is going to be equal to y2, which is 7, minus y1, which is 0, divided by x2, which is 2, minus x1, which is 3. So our slope m is going to be, what is 7 minus 0?
7
7
over 1.
7. Close, not 7 over 1. What is 2
7
minus 3?
-1.
Negative
Very
7
good.
over 1.
Okay, we accept that. Kennedy, that's your voice?
Hello, yes.
Man, I feel like I ain't heard from you in the whole week. Well, not the whole week. That's not true. At least the Monday I heard from you, and then it's like, where's Kennedy? Where's Kennedy? And then, okay, she made it to the finish line. All right, glad you're here, Kennedy. -7. So the slope is -7 because -7 divided by -1 is -7. Okay, so that's how we got that.
That negative 7 was actually right.
Yeah, that was right.
But that was a good guess.
Very good, Dior and others who are sending in their notes. Very good, man. The handwriting, Dior, I don't know. Wow, your handwriting is very good. Remind me of Miss Cooper when she first started.
You gotta start off good.
Gotta start out good. But this is only the first week. Denario, very good.
This is
Denario,
my honest. We started by 9 o'clock.
it's only 7:31. Okay, so let's do another example. Can I move this?
Yes, sir.
Okay. Very good, Denari roll. Thank you so much. Chianti and Brista. Very good. Alright, so let's move on. So let's do the next example. Alright, so this is another straightforward example. Let's say we have -5 and 3 and 4 and -2 or say -6. Okay, so try this on your own. What is the slope? What will be the slope of this line? Try it on your own. Thank you, Miss McDonald. Very good. Thank you, Chianti. Very good run handwriting. So let me know the answer when you got it.
Is it -1?
Again?
Yeah, I get that answer too.
Again? How do we get -1 again? I was trying to avoid that. Okay. Alright. So
I
let's
mean,
see.
easy I'm surprised.
Say it again?
I say I'm surprised you ain't testing us today.
Ah, yeah. We leave that for Monday to Wednesday. Thursday we can try to behave. All right, so okay, so let's split the screen and see what's happening. So y2, so y1 is definitely going to be -6. Y2 is 3. X1 is going to be 4. X2 is going to be -5. And so M is going to be equal to y2, which is 3, minus y1, which is -6, divided by x2, which is -5, minus 4. So M is going to be equal to, what is negative and a negative? Negative times a negative is what?
A positive.
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 -5 minus 4 is what? What is -5? -9. If you owe someone $5 and you owe a next person $4, how much you owe it altogether?
9.
You owe 9. Okay, what is 6 plus 3? 9. What is 9 divided by -9? What is 9 divided by -9?
-1. -1.
-1. -1. So how did y'all get 7? Hello?
I had to guess 6.
Okay, so how you get
I
6?
got 1.
Okay, that's close.
I just didn't, negative and negative might split naturally, but positive circles come. But
Yeah, no. Yeah,
I'll
be
work
careful.
on that.
Yeah, be careful. So be careful with these stuff. Dior, was that you said -7?
No, so I said -1.
Oh, you said -1. I thought you said negative. Okay, good. Scared for just now. That's good. -1 is correct. All right, thank you, Miss Solana Brown. Okay. Okay, so we's good. Are we good with this concept?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. All right. So what I have not been saying all this while, which is very important, and we can't go much far without it, is we have not been talking much. I mean, I mentioned it, but I didn't really, expound on it and stuff like that, right? But it's very important because we can't do much without it. We can't do much stuff without it. We have to really talk about it before we get further. So remember we said earlier that the general form of, we said this at the beginning, that the general form of a straight line is y equals mx plus b. And we said exactly, we was very good, we said exactly what m is. M is the slope. But we didn't say anything about b. I mentioned it in passing. We didn't really expand on it, and we didn't really, do examples on it. And so for now, we're going to be focusing on what b is, okay? What b is. We only have a few more moments left, so we got to really move. And so m is the slope, but b is what we call what? P is what is B? What do we
The
call
y
it?
intercept.
Y intercept. The y intercept. Okay. B is the y intercept. Now the y intercept. It's important to know what this means. Like, let me say y intercept. What does that mean and stuff like that. So the y intercept is it's very important to know that it is a point. That's all it is. It's a point. The y-intercept is a point. It's very important. Now, when we say it's a point, we know what a point is. A point has two coordinates, x coordinate and a y coordinate. Or I should say, not is a point. It is the point. It is the point where several things happen. Where the value of y is 0. That's one way to define the y-intercept. We also say that the y-intercept is the point where the graph, we could say where the line touches the y-axis. Okay, and so that's what we mean when we say y-intercept. It's the point where the value of y is 0. Very important that it's a point. Okay, it's a point where the value of y is 0. It's also the point where the line touches the y-axis. Okay, and we're gonna explain that, and we're gonna dive into that some more, so we could actually know when we see a line, we could actually say, okay, immediately, boom, that's the y-intercept, boom, that's the slope, just by looking at it. Then we'll be mathematicians, right? Not really, because that's like the basic stuff. But at least we'll be well on our way. Okay, so the y-intercept is the point where the value of y is 0. So we gotta explain what that means, and it's also the point where the line touches the y-axis. And so just on that information, I'm gonna give you all a little test. Now I'm actually testing you all. The other times I was just, now I'm actually testing.
Oh, I still writing it.
Still writing. Okay, someone is still writing. Okay, someone is still writing. Okay, I have to remember that you all are writing and not typing. So yeah, so just remind me of that.
Quick question, right? Will y-intercept always be 0? Just to be clear.
That's where the value of y is 0. That's always the case.
Okay.
Always. Okay. Always the case.
So what that's supposed to mean?
Yeah, so I'm explaining that right now.
I get it.
Okay, good. All right, so let's do an example. So let's say we have this graph. So we have the y-axis, we have the x-axis, right? So y-axis and we have x-axis, and so we have a line. So we have a line, and the line is going like this. And so we have this point right here. Okay, that's the green point. We're gonna call it the green point, and then we're gonna have let's say we have a point. Say we have a blue point. Okay, so it's a blue point right now, and let's say that this is 0. Let's say that this point right here. Let's say that this is 1. Let's say that this is 2. Let's say that this is 1. And let's say that this is 2. My question to you is, which of these points, either the green point or the blue point, which of these points is the y-intercept?
The blue
The
one.
blue one.
The
The
blue.
blue point. Why the blue point?
Because the
Because
blue
the
point
blue
is on
point
the
is on the
y-axis.
y-axis.
On the Y.
Okay,
On
the
the
blue
Y.
one is on the y-axis. That is where the line touches what? The y-axis, right?
Yes, sir.
Yeah.
Yeah. Good. So this is the y-intercept. Okay. So the blue point, or the blue, the blue point, that is what we call, this is the y-intercept. That's the point where the graph of the line touches the y-axis. Okay. Now, can someone tell me, right? What is the coordinates of this point?
0, 2.
0, 2? No, close, close.
2, 2.
2, 2? No, the coordinates. Okay, what would be the y x value? Remember, x value always go first.
Oh,
-2.
Negative 2.
No. What's
0.
the x value? 0. Very good. The x value is 0.
Oh, 0, 0, 2.
0, 2. And comma. And the y value is 2.
2.
2. Good. What did I say here? I say where y is 0? Sorry, it's supposed to be where x is 0.
I was
I
trying to
was
figure
trying to figure
out
out.
why
Yeah,
I
where x is 0,
did.
not where y is 0. Thank you for that. Where x is 0. X is always 0, yeah, so make that correction. X is 0. Okay? So x is always 0 at this point. I'm glad we expound on that. So, and that makes sense because if we look carefully, this is 0, 2. That's the point, 0, 2. Okay? And x will always be 0 at this point. And it makes sense because that's where the graph is going to cut the y-axis. So x has no other choice but to be 0. Okay? So let me give you another example. So let's say, for example, we have, say, this one. And we have, say, let's say we have this line. And so we say we have something like this. And we have another graph. Let's use a purple graph. And this is a purple graph. And this is a parabola, right? And we have different points. So we have, let's say we have this black point right here. So this is a point. We have this green point. That's a point. And we have this, let's say we have a yellow point. Okay. So my question to you, oh, and by the way, let's label this. So this is going to be 0. And let's say that this is 1, 2, 3. Say this is 4. This is 1, 2, 3, and 4. This is 1, 2, 3, and 4. So my question to you is, which point is the y-intercept? Is it the black, the green, or the yellow?
The
The
green.
green.
The green. Very good. The green. Very good. Y'all took so long to answer. What's the problem? Y'all was thinking. What's happening? Y'all waiting for someone else to answer? What is it? Do we understand?
Yes, sir.
Okay. Okay, so So the green is what we call the y-intercept. Why is that the y-intercept?
Because it's on the y-axis.
That's where the graph of the line, let's be precise, that's where the graph of the line touches what?
The y-axis.
Touches the y-axis. What's this point though? What's the coordinate of this point?
0,
0, 4. 0, 4. Okay, 0, 4.
Hold on. So the coordinates for that y-intercept would always be a 0.
A 0 first. That's what we mean when we say the value of x is always 0. Okay? You understand what I'm saying?
Okay. So you're just trying to figure out the coordinates for the y-intercept. So the x wouldn't be relevant.
Exactly. The x isn't relevant. The x is always 0. Okay? So for the y-intercept, that's the point where, like we said, it's the point where the value of the value of x is always 0. Always 0. That's where the graph touches the y-axis. So here, this will always be 0. The y-intercept will always be 0. The x value will always be 0. And we're just worrying about the y value. It's so bad that and like you said, Mr. Bethel, you're really only concentrating on the y value. So in some cases, when people say y-intercept, they only mention the y value. So people say, okay, what is the y-intercept? People just say 4, right? Or what is the y-intercept? People just say 3, because you really only concentrate on the y value. But that technically is not correct, right? Even though in practice we do that, the y-intercept really and truly is a point. Okay, it has 2 coordinates: the x value and the y value. But we already know that the x value is 0. So when we say, okay, the y-intercept is 4, we already know that the x value is 0, so we don't even say it. Okay. All right. So someone is say they're waiting to join. How is that so? How is that so? Oh, sorry. Yes, they are waiting to join. Okay, sorry about that. It's the person who just joined. Let me go back to what we was doing now.
So if they have that with the y, do they have that with the x too?
Yes, sir. You read that right. So they have it with the x-intercept. I just didn't want to introduce that now, but this would be the x-intercept right now, where the graph of the line touches the x.
Aren't they the same thing? Just one is the x, one is the y.
What do you mean the same thing?
Like they have the same function, to locate them.
Yeah, the same way you locate them. When the graph touches the y-axis, we say it's the y-intercept. When it touches the x-axis, we say it's the x-intercept. Now, they don't have to be the same. In this case, they just happen to be the same number, but they're not always the same number. Okay.
One question, Mr. Taylor. You see how we say 0 and then we say 4 to represent that it's just you're focusing on the y. For the x-intercept, it'll be the same thing. So it'll be like 4, 0.
Very good. So in this case, here, this is the x-intercept. So the point.
That's a question, though, Mr. Taylor.
That's true. That's a statement. That's good. In this case, this is the x-intercept, right? That's just the point 2, 0. Okay. So in either case, the opposite variable is always 0. Okay.
Would you say that's purple line is again?
Oh, the purple line is a parabola. This is a parabola. That's the graph of a quadratic function.
So I asked the arcs, do they have a parabola intersect too?
No, for parabola is just x and y intercept. So for a parabola, it would have two x-intercept, right? Because it cuts the graph right here, and it cuts the graph right here. And then its y-intercept will be right here.
And that's what is that 0 on the y-intercept?
One moment. One moment. Go ahead. Which one? Which one you talking about? This?
On the parabola, yeah.
You mean this point?
Yeah.
This will be the point 0. It'll be the point 0 something. 0 -4 or something. So in this case, the x is still always 0. Alright, let me do another example to make it very clear for us. So let's say, for example, we have something like this. I just want you all to be able to. We only have 5 minutes left. How is that the case? Don't worry, my time is wrong.
It's 6:55, okay?
Yes, that's true. Thank you, Lionel. I mean, sorry, my time. Yeah,
6:55.
my time is wrong. Thank you, Lionel. You have the right time.
Oh, yeah, that time about 2 y'all long.
I serious. I think
Y'all in the wrong
it's
time zone.
7:59.
It's
That's it.
6:55.
Lionel, you come late.
Y'all in the wrong time zone. 7:55.
It's actually my. Don't worry. This is wrong. It's actually 5:55. That's the correct time.
You don't come until 6.
Everybody's early tonight. Everybody's.
Oh, nice.
Everybody. Okay, so let's say, for example, we have another graph. You got to be very careful with this one though. So let's say we have something going like this. Okay, and let's say we have a let's say we have a let's say we have a sinusoidal function. Okay, moving like that. Yes, please, Joy. Where would be the y-intercept? So we're just trying to locate the y-intercept here. Is it here? Is it here? Or is it here? Give me a moment to put the units. So this is going to be 0. This is going to be, of course, -1. It's going to be, of course, -2. This is going to be -1, -2, +1, +2. This, of course, is going to be 1 and 2 and 3. So the question is, which of these points is the y-intercept?
Green.
Sorry, the red, the blue, sorry, the green, the blue, or the purple?
Green.
The green. Why the green?
Because it's
Because
on the
it's on the
y-axis.
Okay. Okay, one moment. Okay, yeah, it's okay. So good. So we have so it's gonna be definitely the green one. Why the green one?
Because it's on the y line.
It's on the
That's why the slope
y-axis.
intersect the y-axis.
No, not where the slope intersect the y-intercept. Not where the slope intersect the y-axis.
Where
Where the graph of the line, intersects the y-axis.
Watch this.
Okay, so definitely you're right. So this is going to be the y-intercept, where the graph of the line intersects the y-axis. Okay.
So is there a rule that you only have one line?
Say it again.
Is there a rule for only one line?
Is there a rule? I'm trying to figure out your question. What you mean?
Like, can there be more than one line
You mean on the same graph?
on the same graph?
Yeah, definitely. We could have multiple lines on the same graph. So I can show you. So y-intercept, what's the y-intercept for this one?
0, -2.
0, -2. We already know that x is automatically going to be 0. And so we just focusing on the -2. Why it's -2? This is where -2 is. And x is automatically 0 for y-intercept. So we don't need to worry about that. We just worry about -2. Okay?
So why is X for the like it's the opposite for the X intersect or no?
It's the opposite for the x-intercept. Okay?
Alright.
Alright. But we're not focusing on x-intercept. Now I just really want you to understand y-intercept. That's why I'm not really focusing on that. So let's say we have another one. What time? What's 8 o'clock? That's going to be our last example. So let's say we have someone asks about different lines being on the same graph. We could have that line. We could also have this line, and we could also have this line. And so my question is, locate all y-intercepts. Locate all y-intercepts. So tell me.
The bottom blue.
The bottom blue? You mean here?
No.
You're not gonna label that?
So we
Are you gonna label it?
-2.
No, I'm not gonna number it. We're just locating because we all the time.
Yeah.
Wait, you mean here?
No, on the y-axis.
No.
On the
Where?
y-axis.
Here?
There's a line.
On the y-axis.
The y-axis. Here.
It's
No,
between
the
the
purple
purple
line.
Zero on the
Is it the purple line?
The purple line. Here.
Yeah.
Oh, this is the y-intercept right here.
No.
No. They're the
Calm
same.
down.
Okay,
Go
so
down.
the first. This?
For the blue.
Yes, sir.
This?
Yes.
This is the y-intercept. For which line?
For the blue line.
For the blue line. Very good. So this is the y-intercept.
Gee.
Alright. Okay, and this one is the y-intercept for which line?
Purple.
The purple.
Purple. Very good.
No, on above. For red.
And then for the red one, we could use yellow. This is the y-intercept right now. For which line?
Red.
For the red line. So it's the y-intercept. So the y-intercept is the point where the graph of the line intersects with the y-axis. So let me label it. This is the y-axis and this is the x-axis. Okay, so we know what is the y-intercept. We know it's the slope. So hopefully next time when we come, we could really unpack the idea of how we actually put them ideas together to give us a line, and how we can actually go about graphing our lines using those ideas. Using those ideas. Okay. Any questions for me?
No, sir.
Okay.
No, sir.
Okay, that's good. Do you feel like you learned anything?
I have one question.
Go ahead. Go ahead.
This was back when y'all was doing the first method
Okay.
of finding the gradient.
Uh-huh.
Yeah, I didn't understand how y'all was getting that half.
I mean, sorry, hang on. I mean, Which one? You mean this?
Yeah.
Okay.
Like saying you have 1/2 and x.
Okay, so you understand that we just divide both sides by 2.
Yeah, I understand that.
And then we get x over 2 minus 5 over 2.
Yeah.
Okay, but so you're trying to figure out how we move from x over 2 to a half.
Yeah.
Okay, all right. Notice that if we have, let me get a clean slate. If we have 1 over 2 x, that's equal to 1 over 2 times x over 1, which is equal to, what is 1 times x? X. What is 2 times 1? 2. So that means that x over 2 is the same thing as a half x. Understand that?
Yeah, okay. I didn't saw this part.
Okay, that's the thing. Any other questions?
No, sir.
No, okay. All right. So for those who are leaving,
So
go
this
ahead.
the only instance this happened.
It happens all the time.
No, I mean like with the half, we could get a half.
You could get a third. Like, okay, say for example, if I have a third x is the same thing as x over 2, x over 3. Same thing. A fourth,
Okay.
a
So
fourth
once
x.
the numerator is a 1.
Once it's a 1, yeah, we could do that, I think. Okay. Very good questions, Mr. Bethel. Okay, so let me go back to our last slide that we was at.
Isaac,
Yes, sir.
I have a question. It's an example you did. You got 1 over 7. How did you get that?
How did I get the 1 over 7? Okay, I'll explain that right now. Is everyone finished with this before I move this?
Yes, sir.
Pretty good. I just showing the intercept.
Yes, sir.
Okay, so with 1 over 7, that was this one. Okay, so how do we get 1 over 7? Okay, so now Ricardo, you know that we could divide both sides by 7. You understand that part?
Yeah.
Okay. And so once we divide both sides by 7, these two gonna cancel out, leaving us with x over 7 minus 9 over 7. And so we just have y equals x over 7 minus 9 over 7. And so remember the same thing I just was explaining to Bethel. If we have x over 7, we could write that as 1 over 7x. Okay, so we could switch it. Okay, so these two means the same thing, you see what I'm saying? So that's how we get the 1 over 7 to be the slope. You understand, Ricardo?
I following now.
You following? Okay. Alright, so that's how it is. So x over 7, and we could write it. They mean the same thing. Just put in your mind that these two are saying the same thing. Okay, they mean the same thing. So if you have 1 over 7x, that's the same thing as x over 7. And so therefore, 1
So
over
does
7.
that mean you could leave it as x over 7?
That means you could leave it as x over 7 too. And once you know that the slope is 1 over 7, though, you can't say the slope is 7. Okay? Alright. So the slope is 1 over 7. Yeah. Okay. So before you all leave, for those who are leaving the master class, make sure to send your notes in. But for us on this side, we are going to move on to social studies. But before you go, let me see. So again, if you are not taking social studies and RK, you could leave. You're free to leave. All right. If you're not taking social studies or RK, you're free to leave. And I'll see you all on next week. Have a good night. My Bgcse students, I gave you all some work. Some of you all, make sure I get them done. All right, so that just leave us. That just leave us with us who are gonna slave on until 9 o'clock, eh?
I know,
I
right?
know, right?
So
So
tiresome.
tiresome. Who's that speaking? I really want to know the name behind that voice.
This has
That's
to me.
Hestiny. Oh, so Hestiny, you're the one. Okay, now I know. Okay, good. All right, so let's move forward. So this is going to be social studies. So let's set up properly. Okay, let's hope I get the date right. I was messing up with the date.
Are you trying not to test us today, sir?
I trying my best. Today is Monday, Tuesday, Wednesday, Thursday. Okay, Thursday. See, if I even get the computer to tell me, make sure I on point. All right, so this is January. Yes, good. All right, now I'm gonna fix that. I'm gonna fix that before you start. All right, so today is Thursday. What do they want me to fix now? Okay, so definitely our subject is social studies, and the topic. Now, where did we left off from last semester? When we were talking about
We talking
where did we left off?
talking about how to how the
How the
Irish travel
Irish
by
travel by
canoe.
canoe.
I don't know if
Okay,
you
good.
know Lake Erie and all of that.
Yes. So we're gonna talk about here. We're just gonna talk about how they live, and we're gonna see if we can also talk about their ways of getting food. Okay, we might not have enough time for that, but we can see if we can get into it. Okay, now everything I'm telling you here, it's based off of the notes that I have. Okay, I'm not preaching into you gospel or saying you should believe this. Just take it by way of information, and I'm not saying I'm not claiming that this information is true. All I'm saying is this is what you need for your exam. Okay, so don't quote me on none of these things. Don't say, oh, my teacher say I'll wax, and try to say, well, that's fox. Listen, I'm just telling you all what the notes say, and you believe what you want to believe, but I'm not explaining to you all belief system or anything. I'm just telling you all this is what you can need to know for the exam. Okay, so bear that in mind. So don't quote me and say, oh, my teacher say this is that and that gotta be true. No, your teacher was using a book, and that's what the book say. And so the question is, was the book right? That's another question. But is it what you need for the exam? You bet that, right? So that's what we are gonna be considering. So our walks, we're gonna look at. Why are they correcting me? Okay, that's fine. Our walks, how they live. Okay, so we are going to be considering what they want you to know about the Arawaks and how they live. Okay, so keep that in mind. So when I speak and when I talk, do not consider it as fact, just consider it as information. The only way you can consider anything I say as fact is if you study it out and if you come to your own conclusion. Okay, I'm not trying to indoctrinate anyone. I'm just trying to prepare you for exams. Okay, so take these stuff as information, not as facts. All right. Are we clear?
Yes, sir.
Yes, sir.
Okay, good. All right. So how they live? So they lived in they live in like cities with skyscrapers and paved roads and stuff like that. Lucayans.
No, sir.
No, definitely not. The Lucayans lived in villages. Okay, I put built villages. Okay, they lived in villages which were usually built near the sea. Okay. The houses.
Excuse me. Is
Go
it
ahead.
supposed to be Lucans live in villages or live in villages?
Um.
Uh-oh.
That was You didn't see I.
Let's
See,
try.
look again, look again, look again, look again, look again. You didn't see I. It's in.
Funny how you say, I'm trying to make other excuses.
The Lucayans lived in villages. Thank you, Lionel. I was trying to avoid that, but hey, it happened. The Lucayans lived
You still
in.
Texas anyway.
I know, right? The Lucayans lived in villages which are usually built near the sea. The houses, for the ordinary Lucayans were called um, canaes. Okay, as houses for the ordinary Arawaks. Now they were made of wood and thatch. These houses were round with a canonical roof. Now, what do we mean by canonical roof? What do we mean by that?
It's to the darn one of the thing we learned language.
Yeah, not language. We learned it in math.
No, the thingy, the sentence with, like you put the comma thingy.
Oh, you mean we just learned it yesterday.
Some
Some
fragments.
fragments. No, not saying French. You're talking about run-on sentences and how do we fix it?
The
The
semicolon.
semicolon. Not the semicolon. The last one, which when you use a subordinating conjunction. So made of wood and thatch. These were around with a canonical roof. What are you talking about? Canonical? What does that mean?
Like a cone.
Cone-like. Very good. And we saw in maths what a cone is. So the images is as follows. Like the image of it looks something like this. I think we kind of have an idea of what these things is. I'm not an artist, please, but I can try. So you have something like this, something like that, and something looking like that. Okay. So a rectangular. See, they didn't start. So rectangular base, right? And a cone-like roof, canonical roof. And these, of course, made of wood. Okay, so that's what they look like. Okay, so where are we? Okay, so what's up? What's next? So, but that's the houses of the Arawaks, right? The houses of the chief is different. So the chief's house was called, excuse me, was called a buhayo, and it was usually bigger, right? Usually bigger and rectangular. Okay, so I got that wrong. This is not rectangular, it's more spherical, not rectangular. It's more spherical. The chief house is rectangular. This is more cylindrical. The bottom. Let me show you an actual picture. You can see what I mean. The bottom piece was more cylindrical. You know what I mean? Like more like who that is in this chat? Vontae, Heston, Jaden, please pay attention. Please. Please. Uh-oh. Our houses. I was supposed to be taking notes. How y'all get so distracted, man? Okay, so this is a good one. So we see the canonical rooftop and the cylindrical base. Okay. So which house is the chief house? Which house is the
The square one is the chief house. The same with the chief room.
Yeah, this one is the chief house. This one is the our home. This another one. Okay, this one is a typical one. Okay. Pretty nice design, man. I mean, that's it'll be cool to not live in one of them, but at least to sleep in one of them for at least a night. See how I feel. Pretty cool.
You ever saw it, no?
In real life,
Yeah.
I had to build one for a project. Anyone had to build
I
one?
live near one.
Or you live
With the
near one?
plastic straws.
The chief house was a boohoo, usually bigger and rectangular. I made mine with a paper. I remember building them, boy.
No, I said story one.
Oh,
You got the materials for that.
I don't. You ever saw an actual one?
Yeah, I saw it.
Okay. The house had very little furniture, so it's very empty. So no sofa and no big sofa and everything. Very little furniture and utensils. Just a few clay. Just a few clay pots. Just a few clay pots. Guards and hammocks. What are hammocks?
They big.
The stuff. Hammocks are pretty nice to sleep in. Anyone ever slept in a hammock?
They got to chill outside, right?
Yeah.
Right on that.
Yeah. Chill outside. Fall asleep, lay down.
Mosquito.
Well, minus the mosquitoes. So cooking.
They want to stay outside, right?
And eating was done outside. Okay. And often under canopy. Is Jonathan here?
Something.
Yeah. Nearby were Israel?
I saw him in chat.
Okay. Nearby were gardens for herbs and plants. So they was very simple. You could describe them as very simple, not too much going on, very humble lives, and primitive. Because when we say primitive, we mean, not using a lot of sophistication, right? Compared to our day where we have, hammocks wrong? What do you mean? Inside this?
Or
Which
whatever
one?
that word is.
This one?
Right there. Yeah, you spell it wrong.
I spell it wrong? Hammacas. That's right. That's the way how they pronounce it. That's or the
But
way how they
it
write
have
it.
the O though.
No O. Hammocks. This hammocks and this hammacas. Yeah, it's the yeah.
Okay. Sorry.
No problem. That's fine. That's fine. I know. I always make mistakes sometimes, so you could correct me if you see something. That's good. Okay, so herbs and plants. Okay, so further away. Further away were they are fields. Okay, so there are fields the name for their fields is Conacus. Okay, Conacus. That's the name of their field. And of course they would have a field, but their field is further away from their home. That's the field for their crops. Now they're pretty different from us. Can anyone tell me differences you see immediately from the Arawaks, how they live compared to us?
They live in hammocks.
They sleep in hammocks.
They
As
always
compared,
Peaceful.
their house is more peaceful. I like that.
they cook outside and eat outside.
They cook outside and eat outside, and we don't do that. At least not as often as we should. One thing about their life is that it's definitely more it's more they garden and they agriculture. You know what I mean? So that's something. So that's big for them. Say it again.
And go to the food store.
Yeah, they don't have to go to the food store, eh? So that's good. They they survive off of
So no AC.
say no
You
AC.
get the breeze.
You say it again. Yeah.
I know my Wi-Fi.
But what did they say? They say built near the sea, right? So
If it's
definitely
in the ocean.
definitely
No,
they can.
no TV, no
No
internet,
TV.
No
nothing,
internet, no
nothing.
Wi-Fi.
No
They
Wi-Fi.
live in a pig.
No, they live in a peaceful life. No WhatsApp. Nobody watching your
Mm-mm.
status.
Till they get massive.
No, that's tragic. That's tragic.
I say that's tragic. All right, let me see if I have a quiz on this. I might have a quiz specifically on
Oh
this.
no,
Let
no,
me
no,
see.
I did.
I'm gonna admit to the team that I was fun with them games too.
Say the games. It's called quizzes.
I'm
All
not
right.
finished writing this yet.
That's what we need
But
right
it
now.
was
We
fun.
need quizzes like that.
Say I hate quizzes. All right, and you could draw it if you want to.
You could put a draw there.
No, don't draw it. Don't draw it. Take a picture of it. But keep it in memory. Keep it in memory.
I do honors in school today.
You can't be serious.
I serious with my social studies teacher.
Okay, that's good. That means we right on point.
We kind of continuing on from it because we stop at we was talking about their food last year. We had the
Okay.
finish.
I finished all
And we was talking about the priest chair and make gods and all that
Yeah,
stuff.
yeah. That's what we moving on to in short order. Okay, so let's see if we could hammer down a quiz on this. Okay. All right. Give me one moment. Let me wait. Am I still in the meeting?
Yeah.
Yes, sir.
Okay.
That's the
That's
other one.
the other one. Okay. Give me one moment. Let's see. stop presenting. So give me a moment to get this quiz for you.
Okay.
So Kennedy, tell me, where you been? I barely is hearing from you. You barely is coming to class. Where were you?
Swim practice.
You was in what?
Swim practice.
Yeah, that's what they always say.
Yes.
That's what they
I
always
tried to
say.
get my career in.
For
That
real,
is
Mr. Tippetees get me
Swimming?
alright.
Yeah, swimming.
She said swimming. That's pretty good. That's pretty neat. Some of us here don't mind
And
us.
it
Some of us
dead cold.
She was sleeping.
some of us
It
here
dead cold for swimming.
some of us
She was
here can't
sleeping.
swim. She wasn't swimming. She wasn't sleeping. Uh
She was
okay, so
out
that's
partying, so she was doing.
no, she wasn't.
Miss Sec, y'all really don't trust me.
Swimming in this court?
Yes. We have a
For
real
real, who is
swimming
swimming
pool.
pool?
People who
Okay.
want to survive.
Survive what? The battle.
We have to
Okay.
survive for real or something, because I know you know the school.
That's Destiny.
Mm-hmm.
Every time I ask a question, I wish I could hear you all just as much when I as this when I asking questions. Y'all act like y'all didn't hear.
I answer, but if I know none, I go wait till I hear someone answer then.
Exactly.
Okay. Alright, I think we ready.
Real, like.
I think we ready. Okay, so let me share my screen again. Alright. Okay, so let's get back on track. Before your parents be like, what y'all doing in this lesson class? What y'all doing? Alright, so let's begin. Can y'all see my screen?
Yes,
Sir.
Yes,
Okay,
sir.
good. So let's begin. The first question. Lucayans lived in villages which were usually built near the
B.
B.
B. Yes, definitely built near the sea. That's correct. Next question. The houses for the ordinary Lucayans were called shacks, mansions,
Caneos.
See.
canays.
Oh,
Canoes.
That's good.
Not canoes. All right. Let me expand this thing properly. Okay. Next question. Okay, so we confirmed that. Let me restart this. Okay, so the houses of ordinary Lucayans were made up of what? Thatch, wooden thatch and steel, wood and aluminum or cement and wood. A. Very good. A. Very good. True or false? The houses of ordinary Lucayans were round with a conical roof.
True.
Very good. True. What was the name of the Lucayans' chief house? Ohio B. Very good.
Ohio.
Describe the Lucayans' chief house. Big and round, big and rectangular, big and triangular, or big and octagonal.
B.
B. Very good. Y'all looking at y'all notesy.
No.
Wow, at least y'all was honest.
Okay. The houses of Lucayans had huge amount of furniture and utensils. True or false?
False.
False. Very little utensils. Which was not a furniture or utensil the Lucayans had.
E.
These sofas. Very good.
Miss Petite, I can't see the questions, sir.
You can't see the questions good? I don't know. We're using the phone or a computer.
Computer.
Oh, I don't know. Okay, let me try something. Let me stop sharing and then start sharing again. Okay. Okay, so can we see? For the Lucayans, where was cooking and eating done? Inside at the dinner table,
B.
outside,
B.
often
C.
upstairs in the eating lounge, or downstairs in the basement?
B.
B, very good. Outside,
D.
often in the cannery. Very good. What were the Conicus?
The fields.
D.
D, very good. D, the fields for the Lucayans crops. Okay, bonus question. The Lucayans did not trade food with others.
False.
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 False?
That's wrong.
Say
Yes,
false.
sir. False.
What is it?
How is that false? How is that? No, oh my God.
I thought it
How
was
is
They
that
did
wrong.
not
false? I
trade
feel
food with
stupid
others.
now.
Alright, so
Then
next time we're going to discuss more fully this part, okay? And we're gonna finish the rest of this quiz. Okay, so if that's it for social studies, we're gonna move on to, last but not least, religious studies. Okay, so if you're doing religious studies, you can stay. I know, right? I like to end off with religious studies. That's a nice, good.
I like religious studies. Oh, my favorite subject. Religious and maths, my favorite subject. Could drop one day if I have to.
That's,
But too much writing is too much for me.
Slay.
all right. Okay, so with religion. Okay, so the last thing we did we do um did we do the birth of Jesus?
Yes, sir.
That's what we ended with, eh? I mean,
Yes, sir. We end on the shepherd versus the angel.
okay, all right. Okay, so we have to move on to. Okay, give me one moment.
That will be continued or
We have to continue from there. Yeah. So we stopped at the birth of Jesus, and so we need to continue off from that. So give me one moment.
actually we on the shepherds and the angels.
The shepherds and the angels. So we didn't get into. Yeah, the angels would tell them that he would be wrapped in swaddling clothes. I remember that, lying in the manger. Mm-hmm.
But you make
I can look through my religious studies book, right?
Yeah, that's fine. That's fine. That's fine.
Okay.
Okay, so this is supposed to actually be a review for you all because we starting from the ground up. So some of these stories you should know already. Okay, but give me one moment.
Okay.
Please mute your mic because
I know my mic was on mute, by the way. I just was staying. But for I know it's on mute. I just was being annoying.
okay, so let's continue. Okay, so we need to talk about the wise men, okay, and their gifts, and what does that represent and stuff like that. So let's talk about that. So how much wise men came to baby Jesus with the gifts?
Three.
Incorrect. All y'all wrong. All y'all wrong.
How you know? I didn't even know. I say three.
No. Bible never
Yes.
said no. The Bible
I know
never
it's
said
the
that
three
they.
wise men.
No. The
I'm
Bible
sure it's
never
two.
said no.
So
No.
now I gone the four.
It
Hold
was.
on,
Hold
don't
on,
answer
don't
it
answer
yet.
it yet.
It was.
Don't answer it yet. We gotta think.
Think.
It
Yes.
was
Think.
three.
It
I
was
know,
not
I know.
three wise men. It was not three wise men. Bible never said it was three wise men.
Yes,
Yes,
sister
it
did.
did.
Who are the
No.
three wise men?
Your teacher never told you three wise men.
Yes, it did.
No,
Yes.
she did not. No, they did not.
It did. It
They
said three
say
wise
three
men.
wise men.
No. What they
Mm-hmm.
told you all is that it
Mm-hmm.
was three gifts.
Three wise men bringing
No,
three
it
gifts.
was three gifts, not three
That's
wise
how I
men.
always remember. It was three of them. They bring three gifts each
No,
year.
it wasn't just three. We don't know how much wise men it was, but we know for sure it was three gifts. Okay.
It
I
was
hear
All
the
right.
it
wise
was
men.
two or four of one of them.
We don't know how much it was. The Bible never tells us how much it was,
The
but we
Bible
know.
said it was three.
Show me the verse. Show me the verse where it
Watch
say
this.
three wise men. Show me the verse where it
The
say three wise men.
government doing that.
The government say the government lying to us the three wise man.
You might see it in pictures and stuff like that, but it's not. It's three gifts for sure. We don't know if it's three wise
Well, I
men.
just searched it up and it said 12.
Okay. So
Oh, they
the,
gonna smuggle that baby up.
They
it was
they
three
so I
gifts
just
though.
searched it
It
up. They
was
say
three
12
gifts.
wise men who's there.
Yeah, but we don't know how much. Now I don't mind that because they would not, even if they someone say 12, they still can't find you the verse because the Bible never tells us how much wise men. The Bible just tells us that it's three gifts that was
And
given.
movies I watch is always three wise men too.
That's the movies.
Mr. Betty, Google say, however, in the Bible did not say there were only three wise men. There could have been more, been something else.
Exactly. Thank you. All right, the Magi. Okay, so another name for wise man is Magi. Okay, so wise men or Magi. They were astrologers who came from the east. They studied the stars. They recognized the star of David and studied the prophecy concerning this star. It would appear. Can you all see my screen?
Yes, sir.
Yes, sir.
Okay, it would appear at the birth of the Messiah.
I so cool.
Destiny, please, no small talk.
Sorry.
Okay, Isaiah prophesied that men from the east would bring gifts to the Messiah. And that prophecy is found in Isaiah chapter 60, verse 6. Now the gifts that were present, or were presented rather, were the following. What was it? What was the three gifts?
Gold, silver,
Murmur.
Gold,
gold,
frankincense, and myrrh. Very good.
myrrh, myrrh, myrrh.
Myrrh. It's gold, frankincense, and myrrh.
Yeah.
So gold. What does the gold signify?
That is a
He's a
king.
king.
He's a king. Very good.
Yeah, that
Yeah,
is a
that
king.
is a king.
So
Yeah.
this signified that Jesus was a king or royalty. The next gift was frankincense. Frankincense. So you have gold, frankincense. One moment, give me one moment. Okay, sorry. Let me know if I could move on.
Not yet.
Not yet.
You can
You
move.
can move.
I can move? Okay.
One sec.
1 second. So frankincense, this was used in the temple routines, and it was burned ceremonially.
You could go.
Okay, by the priest. Okay, so this gift is said to be an acknowledgement Oh, by the way, sorry. I hope y'all didn't write that yet.
Yes.
Yes.
We did.
Okay.
Did.
Okay then. Since you already started writing it, let me keep it, and then I'll say it afterwards. So this gift is said to be an acknowledgement of Jesus's priesthood, right? Setting him apart from a typical king. So the frankincense, he used that in the temple, and they burned it ceremonially, and the priests used to use that. It's an expensive fragrance used to worship a deity. Okay, so it is a gift to represent that Jesus is not only a king, right, but he is also priest. Okay, so Jesus is both priest and king. Okay, so this gift, or this was an expensive fragrance used to worship deity. Okay, so it means that Jesus Jesus also he's also priest. So he is priest and king. He's our high priest. And the verse that you could use to back that up is Hebrews 4 verse 14 to 17 to 16, that Jesus is our high priest. And then we have myrrh. Okay, myrrh. What was myrrh used to do?
To embalm, like when you die.
To embalm, yes, to embalm the bodies. Embalmment. Okay, so myrrh. So this, did I turn back on the recording? Okay, good. This was also a fragrance used to anoint dead bodies. And so what is that? What was that showing?
He's a Messiah.
No, what was going to happen to Jesus soon?
He was
Oh,
gonna
he was
die.
gonna die.
Yes, he's going to die. Don't say it like that.
Who threw the ointment on it?
That was thing what's her name? Mary Magdalene. She poured ointment on Christ's feet. But the myrrh is also a symbol of Christ's sown death. Okay, so this showed the human side of Jesus and his imminent or soon, that's what imminent means, death on the cross. Okay. All right. So these were the gifts that they gave. Now the wise men went to someone to ask, where is the Messiah is gonna be born. Who did he go to? Who did they go to, Rob? They went to
The king?
the king. What was the name? What was the name of the king?
Period.
Say it again. Herod. Yes, they went to Herod, and they asked Herod, "Hey, where is this baby gonna be born? Who's gonna be king of the Jews?" And Herod was like, "What? A king is gonna be born?" And then Herod said something. What did Herod say?
Bring him
Child.
myself prison.
Yes, bring him so that I could worship him. Bring him so I could praise him. Now, was he being honest, or was he?
No, he was gonna kill him.
No. He had another plan, right? What was his
Chop him
plan?
up.
To kill him.
To actually kill Jesus, right? Herod wanted to kill Jesus. Why did Herod wanted to kill Jesus?
Because he wants to
He
be
was
king.
afraid that somebody was gonna overthrow him.
He don't want nobody to take his place.
Very good. He didn't want anyone to take his place, right? That's foolish, right? That's very foolish. Like, you know. But hey, that's how kings think, right? But but did the wise men know that that was his plan?
No.
No, they's like, okay, no problem. And once we find him, we're gonna tell you exactly where he is, so you can come and worship him. So they fall to his trick, but when they found Jesus, what ended up happening so that they did not go back?
They gave Jesus gold, frankincense, myrrh.
Yeah, but what happened that day? Because they was gonna go back and tell Herod. But what happened so that they would not go back and tell Herod? What happened? It's that what? It's have something to do with an angel.
The angel came back.
The angel came down to them from heaven.
And tell them what?
Yeah.
That some
Don't go back to the king.
Don't go back to the king. So angel came and told them, say, don't go back to Herod. Herod is not telling the truth. Okay.
Yeah.
All right. So let's make a note of that. So Herod, we're not gonna finish it, but Herod the Great, someone's mic is on, please, was always known as the King of the Jews. He ruled over Palestine from 37 BCE until his death. Now, he was a man obsessed with power. Okay, he was a man obsessed with power. The Magi came to Jerusalem and inquired. So they asked of King Herod the location of the Jewish Messiah. Right? Had been born. When the news of the Messiah reached him, speaking of Herod, he ordered the killing of all. I don't like how they read, how they wrote this. I don't like how they write this. Not when the news of the Messiah reached him. When he realized. So the Magi came. Let's fix this. Sorry about this. Let's fix it. So the Magi came and inquired the location. We can say that King Herod did. King Herod told the wise men to come back to him when they found out where the Messiah is born, so that he can come to worship him. But Herod was not speaking the truth. And we're gonna end there, and then we're gonna finish up talking about, okay, so we know he wasn't telling the truth, but what exactly happened and all them good stuff. But it's our time is up, but we're gonna continue this. Gonna pick off with this next week so we could finish up the story. on the wise men or the magi. Okay. Any questions before we go?
No, sir.
He
Okay.
shows a picture of a biblically accurate angel.
A biblically accurate angel?
Yeah.
That's a hard one. I mean, I never saw one in real life, and neither of the people who draw in these pictures saw one in real life.
Weren't they described to like have fair skin?
No, I don't know anywhere in the Bible where they describe their fair
think
skin.
that's how that's somewhere. I don't know if it's true or not.
Not fair
I never
skin.
seen
Certainly wings. We know for sure wings. And their clothes is white. We know that for sure. But in terms of the color of their skin, we don't know. At least I certainly don't
I know
know.
there's somewhere where like they said they were rings with like a bunch of eyeballs on them. I don't know.
Yeah, that's
Yes.
that's eye is eye, I think it is. Okay. All right. So that brings us to the end of it. So please send in the notes, and I will see you all next week. Thank you all for surviving through these entire week of classes. How come we only have 16 people left? Everybody gone. But have a wonderful night, everyone, and I'll see you next week. God spare life.
Okay.
Good night. Good night.
Mr. Books, I need the video from today and yesterday.
Good night.
Okay, one moment. Let me end this video first.